history. I don't want to tell you. So student, what's the next topic? The new topic name is what? Electromagnetic induction. This is very important topic, student. Very, very important. Okay, this is the big B of physics. Other topics are quite easy. This topic is also easy, but you have to understand thoroughly. Okay, each and every point. So let me complete this. Let me start this particular topic. And in the exam, 4 marks compulsory and 5, 6 marks with option. Okay, let me complete the theory because then we will. Once I complete the theory, then we will start one or two numericals. So students, question asking from the students is what is electromagnetic induction? Let me uh, remove electro. Let me explain what is magnetic induction first. Once I explain magnetic induction, then I will explain what is electromagnetic induction. Okay, and the terms related in the electromagnetic induction, then I will explain. So all of you concentrate. Everyone, please concentrate. What is electromagnetic induction? Before that, let me explain what is magnetic induction. Magnetic induction, already we have done two topics of magnetism. Okay, one is what magnetic field due to electric current, and second is what magnetic material. Already we know the term magnetism. Okay, so you know the symbol of magnetism, magnetic induction. That is what B, capital B. What is exactly magnetic induction? So you know that already we have done, but still let me define the what is magnetic induction. So as we know, every magnet, uh, from the magnet, some flux are what coming out. Okay, magnetic flux. Those particular magnetic lines are called magnetic flux. So, so every magnet has some area. So from every area, some magnetic flux or magnetic lines are coming out. So that particular magnetic flux per unit area is called magnetic induction. Remember this. So mathematically, how we can say magnetic induction is what? Flux per unit area. Remember this formula. Magnetic induction is what? Flux per unit area. And it is given by the formula. Already I have given flux B is equal to flux upon area. If I change in flux, change in area. Okay, you can say like this also. So students, I can write from this particular formula what is flux. Flux can be written as what? B into A. That is what? Magnetic induction into area. Magnetic induction into area. Remember this. Students, what is unit of this particular flux? Unit of flux is what? Weber. Okay. And what is unit of area? Meter square. So this is unit of what? Magnetic induction. Okay. So unit of flux is what? Weber. Unit of area is what? Meter square. Weber per meter square can be written as, you know, the another name, Tesla. Okay. The another name of is what? Weber per meter square. So we can say Tesla also, or we can represent it by what? Capital T. Capital T. Understood? So this is what unit of magnetic induction. This is what simple. This question will ask for what? 1 mark. Now we will come to the point. What is electromagnetic induction? So what is exactly electromagnetic induction? I will just let me tell you. Students, if you take magnet, and if I take one coil, okay, one circular coil, if I take metal, that coil is what? Made up of metal. And if I take a magnet, and if I move this magnet up forward and backward direction, and if I keep galvanometer उस particular coil के बीच में, if I put ammeter or galvanometer, you will find some deflection into that galvanometer. Why does such deflection occur? That due to magnet, this is not due to magnet. Due to magnet, some electricity or some voltage is generated into the coil. I will explain you into the next question. That time you will understand. But only you remember, if I take one magnet, this is suppose this is a magnet. Okay, this marker is what? Magnet. And if I take one coil, if I take coil, and if I just move this magnet up forward and backward direction, and you will find into the coil there is a EMF is introduced, induced. EMF means what? Electromotive force. What is the electromotive force? Means what? Electricity, that is voltage. Okay, so remember this. So this phenomenon is called electromagnetic induction. So what is the electromagnetic induction? Let me define the definition. It's a process or phenomenon of producing induced EMF. We are not providing the actual battery. We just keep coil over there and we move magnet forward and backward direction. So if I move the magnet coil forward and backward direction, there is a EMF is induced in the conductor or conducting coil due to changing in flux. Actually, you are asking, sir, why if we move magnet up forward and backward direction, why that electricity is generated or why EMF is induced? Because of changing flux, changing in flux, changing flux. Okay, flux is cut by the coil. If I keep this magnet, so along this magnet there is a flux. Okay, and if I take a coil, so when I move magnet up forward and backward direction, that flux is cut by the coil. तो coil उस flux को cut करता है. And according to Faraday's law, I will explain you after this. Faraday's law states what? Faraday's law states that if there is a change in flux, EMF is what? Induced. Such phenomenon. Now only understand the definition. Due to changing in flux, EMF is induced. Such phenomenon is called electromagnetic induction. Only remember this because in the next question, I will explain using what some concept and diagram. Okay, don't worry. Now just understand the definition. Electromagnetic induction is that process where EMF is induced, voltage is induced due to changing in flux. Only remember that. And magnetic flux, magnetic induction, you know that flux per unit area. Now next question. Some relation I want to explain you that you know already we proved flux. That is what phi is given by B into A. But what is exactly into the vector in the vector format? So what do you mean by magnetic flux? My question is what? Already we understood flux, okay? But what do you mean by magnetic flux? One question will come into the exam. What do you mean by magnetic flux? The total number of magnetic lines, as I told you. What is exactly flux? Flux is what? Total number of magnetic lines passing normally through the given area of the magnet is called the magnetic flux through that area. So, for example, if I take this particular area, ds, what is the area? Ds. Okay, this ds bar is what? Perpendicular to that area, and this is direction of magnetic induction. Angle between them is what? Suppose theta. Okay, so we observe that if I found out, so what I will get, b bar dot ds bar is the formula. Okay, so flux, change in flux is given by b into ds multiplied by cos theta. That is the formula. Remember this. Okay, and if theta is 0, students, if theta is 0, what is cos 0, students? Who will tell me cos 0? Cos 0 is what? 1. So what is change in flux is given by B into change in area. Okay, this is the formula. So already I told you what is flux? Magnetic induction multiplied by A. A stands for area. Here also B multiplied by ds. What is ds here? Area of that particular magnet. Okay. What is unit of magnetic flux? You know that. What is the unit? Already I told you. Vapor. And what is the dimension? Remember the dimension of magnetic flux. Okay, m raised to 1, L square or L2, T raised to minus 2 or T minus 2, A minus 1. Remember this dimension. Okay, this is very important for MCQ point of view. Hope so you understood the definition and the concept of magnetic flux. Please copy.